All right, let's go through this one. Let's have a look at what does it mean? What is it saying? Break down the question into maybe smaller components and then see if you understand each component. The diagram shows a sector OAB. There's O, there's A, there's B. It's pretty straightforward. It says what it is what it says, right? The sector. The center is O, which means that it could be a circle, but it's not. It's a portion of a circle. It's a fraction of a circle. It's a fraction theta out of 360 of a circle. And it has a radius of r, which means that if this is a radius, surely that's also a radius, this whole length. And angle AOB is theta radians. Got it? The point C on OA, the point C over there on OA, is perpendicular to BC. It's 90 degrees to BC. I can see that. Good. The point D is on BC. You can see that. And the circular arc AD has center C. All right, so this is another smaller circle that you can draw inside it, or part of that sector. Which means that this is like radius, call it radius 2, if you want to call it, second radius. And it says here, that makes sense. It says here, the point D is on BC and the circular arc 80 has center C. So they're not really telling us what the length of this is. It looks like it's halfway, but they're not really saying it. They're not saying BD is equal to DC or stating that. First question now asks us, find AC. Let's find it first. So there's AC there in terms of R and theta. So just find AC basically. R and theta will come up on its own as you work it out. So if we're working out AC, I can see that it's a portion of the radius, R. It's also a radius of this entire quarter of a circle. All right, so maybe we can call it something. We'll just call it X or something. Let's call this X. We call this length X. And what do I have here? I have a right angle triangle. So what two things do we think about when we see right angle triangle? 90 degrees or Pythagoras Theorem, right? Yeah. Now, if I want to find that length X there, all right, I got it now. I still haven't solved it myself, honestly. I'm just thinking, how do I find AC? If I find this length, I can minus it from R, right? Can you see that? Let me draw it in here. Can you see that OA minus OC is going to equal X, right? But what is OA? OA is R. So all I need is OC. So if I can find OC, and I see it's in a right angle triangle, I can see that this side is also my adjacent side. And what's adjacent over R? Cos, right? So cos of my angle theta is equal to OC over R adjacent over hypotenuse. So if I go R cos theta, that's going to be OC. And I've now got OC, which is R cos theta. Now, why did I need it again? Because I can now find AC. So basically, AC is equal to OA minus OC. We've just found OC. And we know what OA is. It's R. This is going to be R minus R cos theta. As long as it makes sense for now. Don't beat yourself up if you didn't get it. But pat yourself on the back if you understand. Right? Stepping stone, right? Start from there. So if you understand this, that's good enough to be able to do it again. All right, so let's go to the next one. Find the perimeter of the shaded region ABD. Now we want to find the perimeter. So we got to add that up, and add that up. When they give you two questions like this, they normally want you to use the previous question to get the next question somewhere along the line. So what we want to do is we're going to label whatever we got in the diagram. I'm just going to erase that. Let's just label what we got. All right. So this here is going to be r minus r cos theta, if you can see that. What will this length be? What will CD be? Any idea? I'll give you a hint.
Same.
The same. Good, because it's a
Radius.
radius. Okay, good. So that's going to be r minus r cos theta. So that's going to be CD. So all I need now is BC, right? Just like I found OC. How do I find BC in this triangle? BC is my opposite, right? It's the opposite side. That's my hypotenuse. So what do? I go sine of theta is equal to BC over R. That over that. That's going to be R sine theta equals BC. So that's going to be in terms of R and theta. Do what you can. I could do trig, so I did it. All right? I couldn't do Pythagoras Theorem because I needed another side. But if I had another side, I'd use Pythagoras Theorem. So that's going to be R. That's going to be OC. Got it? So I've got this length. So I can now find this length by subtracting BC. So BD, by the way, the perimeter, let me first write the formula for the perimeter, right? So the perimeter is going to be of this shaded region is going to be BD plus the curve AB plus the curve AD, and that's going to be what I want. Now we just found BD, and we're saying that BD is equal to BC minus CD. And that's the same as BC, which we're saying is R sine theta, minus CD, which is R minus R cos theta. Okay. Keep it in a bracket because that negative is going to become a positive. And that's going to be BD. So that's going to be R sine theta minus R cos theta. All of that is BD. Now, let's find AB. AB is arc length. Remember, arc length is theta R. How did we get that? Theta over 2 pi multiplied by circumference. 2 pi R, that cancels, leaving you theta R. So that's going to be theta R, stays theta R. That's R, that's theta, so that's theta R. So theta R plus AD. AD is 90 degrees as the angle. So this is going to be pi over 2 now. And the radius is not R. The radius is R minus R cos theta. So the same formula applies here, theta R. But my theta is now 90, and my radius is now R minus R cos theta. So theta is going to be 90, which is pi over 2, and my radius is R minus R cos theta. Now I've got a little bit of manipulation to do. These two look the same, R minus R cos, R minus R cos. Let's say this was K minus 1 plus half pi K. We could minus it, right? We need to. All right, just a bit of neatening up here. End up with R sine theta minus R plus R cos theta plus theta R plus pi R over 2 minus pi R cos theta over 2. And I can then collect like terms, etc. I can actually see them. So this is going to be R cos theta and minus pi R cos theta. I can take out cos theta from there. I can also take out all those R's. Anyway, there's a bit of a simplification process there. I don't want to spend too much time on that. Simplify it. But if you got it understanding until here, if you can see what BD is, what AB is, and what AD is, this part here, that's the gist of the understanding of this. Rocket science. But I'm just, you're going to work for NASA. You're going to measure the trajectory of the moon as the moon moves from A to B, while one of, what's the guy's name? A famous guy who's putting satellites up. Elon Musk's satellite is Theta, and the moon is suddenly moved from A to B. What is the distance that the moon traveled around that satellite? I don't know. It could be anything. But it's physics. Okay. Alrighty. Let's go to the textbook now. Let's see what are you all doing at the moment in class? Yeah, I'm gonna stop the recording here.